Blended wing-body aircraft. Is this the future of air transport?
Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today.
In aviation, higher performance has always boiled down to two factors: power and structures, particularly the aerodynamic form of airframes. And in airframes, the typical way to work that problem is to develop wings that produce maximum lift with minimum drag and fuselages that enclose the desired payload, again with minimum drag. Now, most aircraft today stick with the formula of a century ago: a cylindrical fuselage suspended by wings for lift. But what if the wing and fuselage could be incorporated into a single shape? Will the result improve efficiency? Well, the USAF thinks so and has contracted with Long Beach, California-based JetZero to develop a blended wing-body jet, which the company claims will have unprecedented performance. Compared to conventional tube and wing designs, the blended wing body is expected to reduce aerodynamic drag by at least 30% with additional lift. Now, for military aircraft, this drag reduction will provide extended range, higher payloads, longer loiter times, or combinations of all three. Logistics are crucial in military operations, and the implications for the strategic airlift component of USAF operations are obvious, but the Air Force notes that the technology offers the same benefits for commercial aircraft. The possibility for reductions in jet fuel use are considerable, with the Air Force reporting that about 60% of USAF total jet fuel consumption is burned in transport tasks. NASA is also interested, and the Department of Defense plans to invest $235 million over the next 4 years to accelerate development, leading to an expected initial flight test as early as 2027. The Blended Wing Body program is a collaboration between the Department of the Air Force, NASA, and the Defense Innovation Unit, as well as the DoD's Office of Strategic Capital. Now, the concept is not new. At the end of World War II, the USAF contracted Northrop to build large flying wing bombers, which promised similar performance advantages over conventional aircraft, and the current B-2 bomber fleet also does away with the fuselage, although in the latter case, the primary motivation is low radar observability. And over a decade ago, both NASA and Boeing flew drone blended wing body demonstrators of possible commercial transports. And the other large commercial airframer, Airbus, is also working on the concept. For future commercial airliners, the concept of a blended wing body is intriguing. Scaling the conventional tube and wing designs to carry large numbers of passengers results in a very large aircraft like the Airbus A380. But if the fuselage is also the wing, it's possible to create very large interior volumes for a given maximum payload. This could result in future airliners being weight limited rather than volume limited, resulting in significantly more passenger room. Would you like to fly business class for the price of an economy class ticket? Blended wing body technology might be the answer.
Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.